So, here we present a glimpse of our journey towards our capstone project, that is, design and manufacturing of Savonius wind turbine. So, this is why we needed Savonius wind turbine. So, according to a report of the Economic Times on 8th February 2022, India has a power requirement of 1650.59 billion units, and the peak power demand is estimated to touch 238,899 megawatts by 2025. India is the third largest consumer of electricity in the world, and despite that, nearly 50 million rural homes are without power, which is a huge number to be taken. So, the problems that we have identified are: while using the present solutions of electricity generations, the following problems are faced. Horizontal axis wind turbines are very noisy working and require huge spaces for their setup. The manufacturing and maintenance of these massive wind turbines is quite complicated. Wind turbines is dependent on the wind, whereas on the other hand, 7 years wind turbines rotate regardless of the wind direction. So, after brainstorming and analyzing the problem, we finally found a solution to it. That is to make a 7 years wind turbine, which is a low cost turbine which rotates regardless of the direction of wind. So, we finally made a 3D design of the 7 years wind turbine. The main components that we have incorporated are blades, motor, bearings, shaft, top plate, rods, mountings, and a rectifier circuit. So here is the final picture of our CFD analysis, that is computational fluid dynamics, which shows after applying a wind speed of around meter per second, this is how basically our structure reacts to the wind that we have applied. So here is a detailed drawing of our model and various parts that we have incorporated in order to design a full-fledged model. So here is an image of 3D printed blades by FDM process, which is fused deposition modeling. These 3D printed blades are made by PLA material, that is polylactic acid material. So after the blades, we made a wooden pattern of the design, and with the wooden pattern, we made top and bottom plate by casting aluminium. The top and bottom plate have a thickness of around 6 mm. For smooth rotation of the shaft, we have added a couple of bearings of SKF 6008. Now, in order to convert torque into electricity, we have added a motor here, which is of 4.4 kg/cm. So the motor is now connected to the battery, and after the battery, we have diodes placed which are connected directly to the LED. So after assembling the top and bottom plate along with the shaft and the couple of bearings, we have bolted it down to a basic structure or a basic skeleton of our project. So here is a picture of our final product that we have made after assembling various number of products, that is top and bottom plate, 3D printed blades, motor, spur gear, battery, LED strip. So here is a short video of our model working in motion. So in order to increase the efficiency of the turbine, we have added obstacle shielding, which basically prevents wind from the opposite direction to hit on the blades so that the blade can move in one single direction regardless of which direction it is moving. So this is our team with our project. We have worked really hard on this project and this is what we have achieved. Our team members: Jashanjeet Singh, Kunal Verma, Akshat Gupta, Yesha Sharma, from left to right. A very special thanks to our mentors, Dr. Anant Kumar Singh and Dr. KP Kalyan, for their helping hand on us throughout the journey.